Introduction to the InnoDatabase. Benefits of using the InnoDatabase tables, best practices for the InnoDatabase tables, verifying that the InnoDB is the default storage engine, testing the benchmarking with the InnoDatabase, and when we install the MySQL, this is a workbench MySQL, so we're going to local instance and we are inside. So we can click into the left side to status and system variables, and as you can see on the left hand side we can see InnoDB, that is the buffer pool. We're gonna see in a little bit the InnoDB data, general status. So we have all this information here. And the InnoDatabase is a general purpose storage engine that balances high reliability and high performance. In MySQL 8.0, InnoDB is the default MySQL storage engine, unless you have configured a different default store engine. Issuing a create table statement without an engine clause creates an InnoDB table. And here we have some key advantages of InnoDB. Its DML operations follow the ACID, the ACID model, with transactions featuring commit, rollback, and crash recovery capabilities to protect user data. You can check out this link, the InnoDatabase and the ACID model, row level racking, and Oracle style consistent reads increases, multi-user concurrency and performance. You can check out this link. InnoDatabase tables arrange your data and these to optimize queries based on primary keys. Each InnoDB table has a primary key index called the cluster index that organizes the data to minimize the input-output for primary key lookups. And you also have the link cluster and secondary indexes. To maintain data integrity, the InnoDatabase supports foreign key constraints. With foreign keys, inserts, updates, and deletes are checked to ensure that they do not result in inconsistencies across the related tables. There is the link, the foreign keys constraint, and this is the InnoDB storage engine features. So we have this column with features and support, and you can read all the stuff here. We have the InnoDatabase, or the InnoDB enhances and new features. We have that. We have the additional InnoDB information and resources, and we're gonna move to the next section. Okay, so we have some benefits of using the InnoDB tables. The InnoDB tables have the following benefits. Let's just check out this first one. If the server unexpectedly exits because of a hardware or software issue regarding of what was happening in the database at the time, you don't need to do anything special after restarting the database. InnoDB crash recovery automatically finalizes changes that were committed before the time of the crash, and undoes changes that were in the process but not committed, permitting you to restart and continue from where you left. So you can check out also this link, the InnoDB recovery. Okay, so we have the InnoDB storage engine maintains its own buffer pool. We have here, for example, here we're gonna see the InnoDB buffer pool, as you can see here. Okay, the buffer pool that caches table and index data and main memory as data is accessed. Frequently used data is processed directly from memory. This cache applies to many types of information and speeds up processing. On dedicated database servers, up to 80% of physical memory is often assigned to the buffer pool. So we have this link if you want to check it out. If you split up related data into different tables, you can set up foreign keys that enforce referential integrity. If database becomes corrupted on disk or in memory, a checksum mechanism alerts you to the VAGAS data before you use it. The InnoDB checksum algorithm variable defines the checksum algorithm used by the InnoDB. When you design a database with appropriate primary key column for each table, operations involving those columns are automatically optimized. It is very fast to reference the primary keys columns where clauses, order by clauses, group by clauses, and join operations. So you have that, and you have some more information here. For specific tuning techniques you can apply to your MySQL server and application, you can check out the optimizing for InnoDB's tables. And let's move to to the next section. You have best practices for the InnoDB tables, and let's just check this first example. So this section describes best practices when using the InnoDB tables. Specify a primary key for every table using the most frequently queried column or columns, or an auto increment value if there is no obvious primary key. So let's move on. Now, verifying that the InnoDB is the default storage engine. Okay, so issue the show engines statement to view the available MySQL storage engines. Look for default in the support column. So I already log in with my credentials, so I type in show databases, and now I just use my common query database. So it's not mandatory to do it, but what we are gonna do is just type show engines like this. So show engines, and we're gonna end it up with a semicolon. And as you can see, if I make this bigger, I'm gonna have memory mrg underscore myasm, the CSV, we have null, myasm, InnoDB, black hole archive. So we have all that. Now, alternatively, query information schema engines table. So let's try it out, this one, and it's gonna be select. Okay, so let's move it here. It's gonna be select asterisk, so select from all columns from the information underscore schema, like that engines, and then end it up with a semicolon. So we press enter, and again we're gonna get the same information. So as you see here, so we have the memory, the mrg underscore myasm, all the stuff until the end. So let's move on to the next section. Okay, so now we have testing and benchmarking with InnoDB, and let me see. So let's just read this first paragraph. So if InnoDB is not the default storage engine, you can determine if your database server and applications work correctly with InnoDB by restarting the server with the $default storage engine equal to InnoDB define on the command line, or with the default storage engine equal sign InnoDB define with the MySQL section of the MySQL server option file. So, and here they give you an example for each table. Alternatively, to run test queries and other statements without disturbing the original table, you can make a copy. So create table, then you type some code, engine equal to InnoDB select from all columns, and then other engine table. So let's move to the next section. And now we have the InnoDB and the AZ model. So we have that, we have let's go for the atomicity, we have consistency, isolation, and durability. So you have all that. Let's move to the next section. We have the InnoDB multi-versioning. Okay, so we have the multi-versioning and secondary indexes. Let's go to the next section. Okay, so we have the InnoDB architecture. As you can see, we have the InnoDB architecture and memory structure on these structures. So you have, this is the buffer pool. Okay, this is a memory structure. We have the buffer pool, the change buffer, the log buffer, adaptive hash index. Then we have on this structure, we have the change buffer, we have the double write buffer files, we have the undo table spaces, general spaces. Let's move to the next section. Okay, so here we have the InnoDB and memory structure. So here we have the buffer pool, the change buffer, adaptive hash index, and the log buffer. So here we have the buffer pool. This is the one that we're gonna see. See here, InnoDB buffer pool. So the buffer pool is an area and main memory where the InnoDB caches table and index data as its access. The buffer pool permits frequently used data to be accessed directly from memory, which speeds up processing. On dedicated servers, up to 80% of physical memory is often assigned to the buffer pool. For efficiency of high volume read operations, the buffer pool is divided into pages that can potentially hold multiple rows. For efficiency of cache management, the buffer pool is implemented as a linked list of pages, the data that is rarely used and age out of the cache using a variation of the list recently used. So we have the LRU algorithm, knowing how to take advantage of the buffer pool to keep frequently accessed data in the memory is an important aspect of the MySQL tuning. So here we have the buffer pool, LRU algorithm. Here we have the buffer pool list, so we have the head, this is the new sublist. Here we have the unused pages, access pages, the tail, head, all lists, evicted pages. So we have all this information here, you can read it up. And let me see, monitoring the buffer pool using the database standard monitor. So we have the buffer pool in memory, you have all this stuff. We have this table here, InnoDB buffer pool metric. You have the name, the description, total memory allocated, the total memory allocated for the buffer pool, and the bytes. So we have that. And now we're gonna move to this final section. Okay, so we have the change buffer. The change buffer is a special data structure that caches changes to secondary index pages when those pages are not in the buffer pool. The buffer changes, which may result from the insert, update, or delete operations (DML), are merged later when the pages are loaded into the buffer pool by other read operations. So this is the change buffer. So this is the buffer pool. We have the periodic purge of secondary index pages. To this change to secondary index pages, we have the periodic merge of secondary index pages. So what else? Let me see to check out some example here. Okay, they're not giving us an example. Let's try it out here. Okay, monitoring the change buffer. The following options are available for change buffer monitoring. The InnoDB standard monitor output includes change buffer status information to view monitor data, issue, show engine, InnoDB status statement. So let's check it out. Okay, so we're gonna type in show engines. It's gonna be like this, show engines, and it's gonna be InnoDB status, and then / uppercase letter G. And okay, show engines. Let me see, show engine without that S. So we have that. We can press, then we press enter, and this is all that we have here. So let's do it again. Show engine, InnoDB status / uppercase letter G. Okay, so we have the raw operations and of InnoDB monitor output. We have the buffer pool in memory. We have the log. We have the insert buffer and adaptive hash index. So we have all this information. We have transactions, smartphones, background thread. Okay, so we have all this. Now let me go to so this is the example that they're giving us here, show engine. Now change buffer status information is located under the insert buffer and adaptive hash index heading and appears similar to the following. So as you can see, insert buffer and adaptive hash index. So this is the one that we saw here in the way in the top here. Let me see, it was insert buffer and adaptive hash index, as you can see over here. And now what else do we have here? So now we're gonna see, for more information you can check out this link. The information schema InnoDB metrics table provides most of the data points found in the InnoDB standard monitor output plus the other data points. To view change buffer metrics and a description of each issue, the following queries. So we can just copy this one, but let's just type it in. So it's gonna be select name, comma, it's gonna be comment, and it's gonna be from and information, like that, information underscore schema, and it's gonna be that InnoDB underscore metrics, like this. So, and it's gonna be where, so we're gonna use this clause where name, like, and inside single quotes we're gonna have the percentage sign, and it's gonna be eboof, like that, and we're gonna end up with a / uppercase letter G. Okay, and we don't have to put a semicolon at the end. We just press enter, and this is the result that we are gonna get name, comment, as you can see over here. So it's 17 rows. Okay, so now the information schema. InnoDB buffer page table provides metadata about each page and the buffer pool, including change buffer index and change buffer bitmap pages. Change buffer pages are identified by page underscore type. ebuf underscore index is the page type for the change buffer index pages, and the ebuf underscore bitmap is the page type for the change buffer bitmap pages. So we have that. So let's check out this example. You can query the InnoDB underscore buffer underscore page table to determine the approximate number of ebuf underscore index and ebuf underscore bitmap pages as a percentage of total buffer pool pages. So let's just copy maybe this example, and yeah, so let me see, what do we have here? Okay, so let's just type it in. So it's gonna be select. Okay, so we're gonna select, we're gonna open parentheses, and again we're gonna type in select count. We're gonna open close parentheses. Inside the parentheses we're gonna pass the asterisk, and it's gonna be from the information underscore schema that InnoDB, and it's gonna be underscore buffer. It's gonna be underscore buffer underscore page. Let me see. Okay, so now to the next line is gonna be this close where. Okay, where the page underscore type, and it's gonna be like, and then inside single quotes is gonna be ebuf, and then we're gonna end it up with a percentage sign, and it's gonna be as, and it's gonna be change underscore buffer like this, and then underscore pages. So we put a comma, change underscore buffer underscore pages. Okay, that's fine. We're gonna open parentheses. Okay, and it's gonna be select, and it's gonna be count again. We're gonna pass in the asterisk here. Okay, and it's gonna be from information. It's gonna be from information underscore schema that InnoDB underscore buffer underscore page, like that. We're gonna close the parentheses, move to the next section, move to the next line, and we're gonna open again, we're gonna open parentheses. Let me see, let's just open parentheses, and it's gonna be select. Okay, open parentheses again and again, and we're gonna have in change underscore buffer underscore pages slash forward slash total underscore pages, and we're gonna close parentheses, asterisk sign, 100, close parentheses, and finally close the outer parentheses. Move to the next line, and we're gonna type as change like this, underscore buffer underscore page underscore percentage, like that, and then with a semicolon. And let me see, select count from information schema that InnoDB underscore buffer underscore p at line 2. Select count from information. Okay, so let me, yeah, I messed it up somewhere, so I'm just gonna copy and paste it. Let me see, I'm gonna paste it here, and yeah, now they like it. So I type it, yeah, I type it wrong somewhere. Okay, so it's gonna be in select count from information schema InnoDB underscore buffer page as total pages. Oh, okay, so here I messed up this part as total pages, so yeah, but this is the result that we have. So we have 3 columns. We have the change underscore buffer underscore pages is 12, then we have the total underscore pages, that is 8,191, and the change underscore buffer underscore page underscore percentage, that is 0.1465, and we have all that. This is the example, and for more information you can check out this link, performance schema. provides change buffer mutex weight instrumentation for advanced performance monitoring. To view change buffer instrumentation, issue the following query. So let's try it again. So again, let's type it in. So it's going to be select, and it's going to be from all columns from the performance, like that, where the performance underscore schema, that's setup, okay, underscore instruments. Okay, so to the next line is gonna be where. So where the name, like, and then inside single quotes we ended up with a semicolon at the end, and we're gonna have okay, it's gonna be percentage sign, and we're gonna have weight, forward slash, and it's gonna be sync, and it's gonna be mutex, forward slash InnoDB, and forward slash eboof, like that. So we can press enter, and now it works. So we have the, okay, let me see if it's the same. Okay, so we have these columns with name, well, 3 columns, and here we have 3 columns: the name, the enable, time, properties, flags, volatility, documents. So as you can see, weight, sync, mutex, InnoDB, so that's fine. And for more information you can check out this link. And finally we're gonna see the adaptive hash index, and let's just read this first paragraph. Adaptive hash index enables the InnoDB to perform more like in-memory database on systems with appropriate combinations of workload and sufficient memory for the buffer pool without sacrificing transactional features or reliability. The adaptive hash index is enabled by the InnoDB underscore adaptive underscore hash underscore index variable, or turn off at server startup by the double hyphen skip hyphen InnoDB hyphen adaptive hyphen hash index. So that's what we have for the InnoDB.